Good morning, ladies and gentlemen. Sorry I couldn't be here this morning. I had a little tooth issue. So you're going to get to see the presentation I'm giving the other class from yesterday. So we're going to start in on that. The first thing I'd like for you to do, hopefully you picked up all 4 stacks of papers. And we're going to look at what you need to turn into me for the lab. I have given you a paper that explains the calculations that you have to do. Obviously, this whole thing's blank. Eventually, in your report, you will need this chart for every chemical. But for right now, all you're going to do is do your chemical, do the calculation, and report it to the Google Classroom. I will have a file that will open up in there. That'll be a place that you can deposit these so that everybody gets the numbers to fill in this chart. So what you're going to have to do, somewhere in the lab there is a place to look up these costs of dollars per gram of these chemicals. So just copy those into that chart. Then for column 3, you're going to use MC delta T to do the calculation. Now, the reason I didn't write a number here is because some of you did 105, excuse me, some of you did 100 milliliters of solution, some of you did 50. And the mass of your total solutions depended upon if you did 5 and 45, 5 and 50, 5 and 100, or 5 and 105, right? That's I think the 4 possible things that people did. I have told you how to do the correction factor down here for however you did yours. So now, in column 3, you're going to use MC delta T. The only thing it's going to catch you is on the M. You're going to have to add up the mass of your chemical and the mass of the water, remembering that a milliliter is the same as a gram. So for example, if you used 100 milliliters of water and 5 grams of chemical, now please use your exact amount there. If you had 4.98, then you're going to have like 104.98 or something like that. So make sure you do that. C, we're going to make that jump and say, well, that's 4.18 for all the solutions, and then delta T will be your change in temperature for that chemical. So that calculation will go in column 3. Now column 4, you're going to have to multiply by a conversion factor depending upon how much material you used. Look at the 4 scenarios, decide what factor you have to multiply by, and then make that correction for that column. So it'll either be 50 over 45, 55 over 45, 105 over 45, or 100 over 45. So you will notice in all cases, delta T will change. It will be bigger than this column. This answer should always be bigger than this answer. Yes? Because all those fractions are bigger than 1, are they not? Okay, good, good. Now, column 5. In column 5, what you're going to do over here is you're going to take, the lab wants to know what would the temperature change be for if you had used 10 grams and 40 milliliters. I'm not quite sure why they don't just have us do that on there. So how do you do that? In column 5, take 10 grams divided by the number of grams that you actually used, multiplied by your answer to column 3. Now, I don't think that's correct. I think I meant column 4. I do mean column 4 right there. That's a mistake. That's column 4. Sorry about that. Let's change that. Bam. So take your answer from this column, and we're going to adjust it to be, yes, okay, I'm sitting here trying to talk myself out of this. That's correct. And then over here in the last column, cost per desired temperature change. I kind of made this up. This is not the same way it's written in the report. I don't like what they want you to do, so I'm going to make it different. So For column 6, take the mass of the solid used multiplied by the cost in column 1 divided by the answer to column 5. So mass of your solid used multiplied by the cost, because what's the cost per gram? So if you use 5 grams, that's going to be 5 times the cost. If you use 10, it'll be 10 times the cost. And then, divide by your answer to column 5. So what that's essentially going to give you is the cost per 10 to 40. And obviously the best one will be the one that gives the best negative, remember, the negative heat, which is the best loss of energy by the reaction per the price. So you're looking for the biggest bang for your buck there. You're looking for where did I get the most temperature change? So this is just an arbitrary number. It's cost per temperature change. I don't know if it's a real unit or not, but let's say that it is. All right. I need those posted yesterday by you guys. I mean, that's your job priority tonight, is to get that done and put up there so that people have to have this to write their report, right? That you got to get that done, because people are not going to be able to do the rest of theirs if they can't do that. So all those, I'll make a place there next period. It'll already be there for you guys. I'll make a place there for you to go ahead and post them, and then it's your job to fill all that in and then make the decision in the report. So let's not write a full report this time. Let's just put down all that data, because that's going to be a lot of calculations. Obviously, you did too, right? So, and some of these are going to be thrown out. The ones that made the temperature go down are obviously ones you can stop right here, probably, because we don't need this data, because we could care less about it. So you lucky winners just have to tell us that it went down, okay? Some of you are not the lucky winners. We'll try to make other people the lucky winners there. So make your judgment on the best hand warmer based on this column. The one that made the temperature go up the most for the least amount of price is the chemical we'd like to use to make the material. Yes, sir. Yes. Oh, no. But then you're going to have to copy those into your report, the others, but that's what you're going to do. I mean, I wouldn't redo the calculation. I just copy somebody else's calculation into my report. Yeah? Yeah. Now there's some, let's go out here and get I'm going to have to do this, I guess. There are some questions at the end of the lab. One of them is actually having you calculate the heat of fusion of ice, I believe. So way down there at the end. Oh, what's going on? There we go. There are 6 questions at the end that you need to put in there. So what do I need this time? Essentially what I need is all your data, all the calculations, an answer to the question, what's the best hand warmer chemical for our scenario, and then answer those 6 questions at the end. And let's say those are due, like the beginning of next week. Yes, sir. Non-toxic, safe for the environment part, you should have already researched that, I hope. So yes, if you get one in there that's really toxic and it's still a good answer, yes. So there is a third factor that I forgot. Glad you brought it up. And that would be if you've got a choice between 2 that are pretty cheap and make it go up a lot, but one of them's toxic and one of them isn't, then pick the one that's not toxic. And it'll be pretty easy to know which one it is once you do it. We had an issue, and you guys that all had the lithium chloride, apparently the lithium chloride had been exposed to way too much air. So the lithium chloride should have been better than it was. And learning a lesson there. To save a little money, I try to buy chemicals in bulk, but some chemicals, once they get exposed, they're pretty much worthless. So what I've been doing lately is buying smaller amounts just for the lab that I'm going to need, because typically the other I won't use it anymore, because or at least for this kind of a lab, I'd need it for something else. If I needed lithium ions for something. Okay, any other questions on the lab? I'm going to close this one out. We're just going to make it its own video, and then I'll start this thing back up. Look for the I'll give you guys the names of the videos to the sub this morning. See you in a second.